So thanks everyone for joining us here today. I'm sorry that I couldn't be in person, but I find this quite cozy actually. So today, as you can see, I'm going to be talking a bit about the evolution of notational systems, but hopefully at the beginning I'll motivate this. Why should we talk about this now? A bit about who I am. From my perspective, I am the founder of the Montreal HCI lab. I'm currently its co-director, Damien Masson, who some of you might know is also my colleague, and we're having a grand old time leading a research lab together. I would like to consider myself a kind of methodological nomad. I don't really have a particular methodology in HCI, so I've done many different methodologies, from more ethnographic studies to building systems to doing psychological experiments. And so because of that, I have many different research areas that I've worked on in the past, but also that my research lab is now focusing on in the future. And so these are just some examples. I've done some current work on human AI grounding. Probably I'm most well known for these interfaces for large language model evaluation. And one thing we're really excited about is work on how LLMs are changing HCI research. And so we have a conditionally accepted paper to CHI 2026, which focuses on this. And so basically, if you are working on an LLM, what we call an LLM integrated system paper, so a paper where you're like reporting some system somewhere that uses an LLM call, then you might want to check out our guidelines. So we propose a set of guidelines on our site that we'd like feedback on. So if you go to my website, you can check out those guidelines. It might improve your paper acceptance. No promises, but. So I'm probably most well known, as Dia mentioned, for ChainForge, which was one of the earliest systems on large language model evaluation. And for prompt engineering. So you can see here, you can compare across multiple large language models. I think the situation with agents now is a lot more complicated than this. And I've given many talks around ChainForge and LLM evaluation, but I felt that, in this current era, AI evaluation research justifiably receives enough attention. So I wanted to sort of bring to you some topic that receives a little bit less attention, but that I've done work on in the past and that my lab is doing research on currently. And so this topic of notations and HCI. And I just want to preface this by saying, this talk is based on 3 papers. One paper which I wrote to CHI 2020, which was on the earliest history of computer programming. A paper I did with colleagues at Cornell to WIS 2022, and thankfully an hopefully upcoming paper to CHI 2026 on how notations evolve. And most of this talk is actually about the last part. So to preface this, what do I mean by notations? I've talked to many different people on this, and they have their various preconceptions. Some people might, when I say the word notation, they might think of music notation, might think of music. Other people I've talked to think of mathematical notation. I have a very broad definition of notation that I deploy and others have deployed in HCI. So everything from this Babylonian tablet here to computer code, to chemical diagrams, to even written natural language, which I won't discuss today, but I do think also counts as a kind of notation. People in HCI probably know this term notation from the cognitive dimensions framework by Blackwell, Green, Petra, and others, which was introduced, I think originally introduced in the 80s, and then was sort of developed by Green and others progressively. And this is a usability framework, so it's kind of heuristic evaluation framework for understanding how good a notation is once you have it. But one of the interesting things is this wasn't an empirically grounded framework in how notations are created and evolved. Rather, it was sort of initially proposed by Green and then sort of evolved over time through many workshops with people who were trying to create notations. And so the question of how notations historically evolve has still been sort of undiscovered. Before I continue on, why should we even be talking about evolution of notations, right? Why should we be studying notations? So of course, everyone here has probably prompted an LLM at some point. And of course, I need to preface this talk by making it very relevant to you in terms of that you can understand, which is AI, right? So since it's AI somewhere. And if you prompt one of these models, this is Gemini, you will get back some response, right? And both in this response, but also in the notations which are under the hood here, there are notations going on all over the place. There's the HTML and CSS styling of the page. There's the fact that this is actually Markdown that it's spitting out, and then it's rendering for me. Within the Markdown, there's like this hodgepodge of, so this is like Markdown, there's a hodgepodge of like LaTeX, versions of mathematics inside there, right? So there's actually a lot of different kinds of notations which are uplifting and showcasing this response. Similarly, if I ask Claude the other day to like code a platformer game for me, it will output something like this. And actually this code, there's a lot of decisions that it's making. Notice I didn't say a particular programming language, I didn't say an API, and all of a sudden it's made a bunch of decisions like I'm going to use React, I'm going to use like certain version of JavaScript. It's kind of hiding those decisions from me. So these notations are uplifting this interaction. And this is what I'd like to call this, we're getting into this stage where instead of having incremental formalization, now we have instant formalization, where we can just input a really, really vague idea and then get an instant formalization that's actually like runnable on machine or is actually like perfectly formalized in mathematical notation. And so you might think of this as formalization as a spectrum, going from these very informal ideas that we want, where we want to encode our ideas very, very quickly, and we have less and less attention span nowadays, and immediately getting a very long formal software system, for instance, out of it. And so this kind of notion of formalization as a spectrum is something that has a longer history in HCI. So famously, Shipman and McCall introduced this notion of incremental formalization. This is a picture of, these are pictures from their articles. And you can see these, like this notion of text and graphics being sort of less formal ideas, and on the right, for them, frames and semantic nets were this more formal part of the spectrum. So positing formalization as informal to formal is a very common sort of move in HCI. But is this how we actually use notations in our practical work? So is this like simple picture of formalization actually how people use notations? Even in like this instant formalization practice, this is really what people do. This is a screenshot of my, a photo of my whiteboard after I think many meetings. And hopefully it's the photo of a typical HCI researcher's whiteboard you sort of can see in some of your backgrounds. And so I don't think this neat picture of formalization really captures how we humans work together. And so I'll give you an example from this whiteboard. You know, we were working on a research project trying to understand how like humans and AI can reach common ground and externalize their common ground. And over the course of this discussion, we started to like adapt Venn diagram notation to represent different assemblages of human and AI. And so we were like, oh, the human's going to be a circle for our purposes and the AI will be a square. And now we can like do a bunch of Venn diagram like things to represent different ideas. And as we were discussing, we started to like amend the notation, right? So we started to realize, oh, maybe we need to like represent external memory documents. Maybe we need to like represent an organization versus an individual. And so we were kind of ad hoc riffing and creating a notation and thinking through our notation as we were working on this research project. And so now that I've shown you this notation, if I just show you this image, right, some of you in the audience can probably figure out what this means or have come to some conclusions about what this means. Maybe it's like 3 humans and then in AI collaborating with one of the humans, and so then maybe the common ground is shared between the humans, right? And if I didn't tell you all of these semantic definitions in advance, and I just started this presentation by showing you this image, you would have no idea what I was talking about, right? So this grounding is occurring constantly. Similarly, I've used notations in my own sort of personal work and practical work. I used to moonlight as a sort of game designer. And recently I was reading this book by Michael Sellers called Advanced Game Design, and he has a really interesting sort of systems diagram notation that he introduces from control theory and ecology. And I was inspired by this, and I was going off to a cafe, and I was like, oh, okay, I'm gonna like use this to understand and unpack the economic dynamics of like my farming simulator game, right? And you don't need to know the particulars of what's going on here, but it's basically like, okay, I like buy seeds from the market, and then like I plant the seeds, and then I get produce, and then so it's sort of this resource allocation and how resources are being added to or subtracted from over time. So here it's like produce will increase the amount of ants, right? And ants will decrease the amount of produce because the ants are like eating the produce. But as I was using this notation, I was also extending it, right? So I was realizing that sellers didn't have a sort of representation for the notion of a constraint. So if I plant the seeds, will they grow or not? Well, maybe that's mediated by soil fertility. And so I'm naturally extending the notation as I use it. And so when humans are not constrained, well, they don't need to stick to these rigidly formal structures. In fact, they can constantly be adapting and inventing notations to ground their communication and their thinking as they work together on problems. And this isn't just something that like happened in my office, right? Does this generalize? And this is something that humans have been doing throughout history. This is a picture from a museum. I was in Greece this past year, where you can see these little clay tokens. And in fact, like some of the earliest histories of notations come from this need to sort of give receipts or inventory or sort of mathematical quantities to keep track of inventory. So going back to our point, is formalization just a spectrum, or is this like kind of an overly simplistic picture? Well, actually, there's something that's being presumed on this right side, which is that we have a formal representation to encode our ideas into, right? When I was showing before, going from code immediately, going from a informal idea immediately into React code, how did React, like where did React come from? I'm presuming a lot here when we do these kind of informalizing moves. And so how did we arrive at this formalism to begin with? So rather than view this as a spectrum, I've started to view it as like a square, where instead of making just this sort of, okay, we just move from informal to formal, maybe there's a dimension of translation where we have an existing formal representation that we can translate into. But there also could be, not always, but there could be a dimension of creation where we're actually creating a new formal representation as we meet a new task. And in fact, how people work, I think, is, at least over the whiteboard, is more of making these kind of formalizing moves, not just in the horizontal direction, but also in the vertical direction. So the AI sort of has the top part covered, right? We can move from informal to at least well-established existing formal representations very quickly. But current AI systems don't have a lot to say about this creation dimension. And in fact, the problem might be even worse than that, in that because AI is really, really good at instant formalization, it's actually incentivizing people to use languages or notations that are already dominant. This is just one such example. This also is happening with natural language, where someone's saying online, oh, now I'm going to default to use Python rather than use a language that I might prefer as a software engineer, just because I think my coding assistant is better using that notation. And so I put this as, current AI systems have a huge blind spot. So they are not intrinsically capable of dynamically evolving new abstractions with us, which they then use to ground later communication with us. So persistence is also an important part here. They might be able to do some of this in the immediate sense, but whether they can ground and meaningfully contribute to the evolution of a new notation is another thing entirely. So for my research lab and some of my upcoming research, this is kind of the overall research statement. How can we design systems that support people in this process of creating, evolving, and formalizing new notations? You could think of this like new abstractions. But there's a problem here, which is that in order to design systems that support people in this process, we need to know what the process is to begin with. What is the process? Can anyone here tell me exactly what the process of creating, evolving, and formalizing new notations is? And I think there's probably a lot of research around this, but it was still unclear to me. I tried to look into it, and it's still sort of very much unclear. So I think we need to be moving forward with a lot more clearer eyes before we tackle the broader question of how we design new systems around this. And so most of my talk today is more of a kind of retrospective, is looking into the history. And so from this, there's an earlier question that we need to ask: how do notations, why are they created? How do they evolve? So there's a number of different questions we need to ask here. So there's a number like here: how do notations evolve over time? What is the process of development? What do we mean by formal? How do some notations become formal? And so what we did over the past year is conducted this like wider scale comparative analysis of the the sort of evolution of notational systems. So we connected what's called a parallel comparative history in history, where we look at the individual historical trajectories of many different kinds of notations, and then we sort of compare and contrast over time to emerge at more general patterns that might not hold over every single situation, but hold over a vast majority of them. And so we looked at things like sheet music notation, dance notations, programming notations, chemical formula, etc. So this is the paper that was conditionally accepted to Kai. Okay, so now I'm going to launch into the sort of historical trajectory. We also discovered stages of notation evolution. So I'll give you the sort of broad overview. How does a notation evolve? Well, the evolution of notation mirrors to some degree the evolution of language, because notation is a form of written language. And so, of course, at its start, someone or a community invents a notation and incubates it before releasing it to a broader community. And I'll go into mostly today this process of what I call here linking and grounding metaphors. I'll give you an example of this. But basically, the initial process of creation is very, very culturally situated and composed of a series of metaphors. And in this stage, you want to create a notation which is really serving a descriptive purpose. It's trying to accurately describe a concept or empirical phenomenon that you're notating. In the second stage, the notation is sort of dispersed to the broader community. People adopt it, communities adopt it, and as different communities adopt it, the notation diverges naturally. And this is just, if you're working together over a whiteboard, for instance, you can adapt that Venn diagram notation, but very quickly, for instance, we go beyond the traditional limits of what that notation was. And so in this stage, the notation will diverge unless there is social and material infrastructure that is put in place to manage the dispersion. And so that will then lead you to the third stage, if you do reach the third stage, which is the institutionalization of notation and its sanctification. So usually there can be a standardization effort or a unification effort where it's usually marked by the establishment of like a standards committee, where a group of people come together and decide that this is the canonical version of this notation going forward. I will get into sanctification a little bit later. There are also these, what we call functional stages on the bottom. They don't exactly map to the social stages above, but essentially a notation proceeds. At first, it's just about describing the phenomena that you're trying to describe. And then you might start to use it to generate theories about the world. Whether that's, we didn't actually perform the dance, but we jotted down the dance, and now we're going to perform the dance, which is kind of a theory about the world. Or that's using chemical formulas to reach sort of conclusions that weren't experimentally tested yet. And finally, if you do reach this stage, not all notations reach this stage, but you might reach a stage of evaluation where the notation becomes a metric on which the world is judged, which I'll get into later. Okay, are we good now? So I'm going to go into just some patterns from our paper. Our paper is very long. Actually, we were told to cut it down, but there's many different patterns, and I can't unfortunately cover all of them. But I'm mainly going to cover the prominent roles of metaphor and cultural adaptation in the early stage of notation creation. Are there any questions at this point? Because I can't really see the chat. Any comments or questions at this point?
I do have one just like clarification question.
Sure.
So earlier you were talking about this kind of informal to formal, and you make a comment that a lot of the LMs are actually not supporting, like from a creation perspective, like informal to formal. I want to learn more about like what would be some recommendations from your side towards like LMs, like in what ways do you think that this is just like language not being expressive enough, or like what are some other ways we should be thinking about to solve that?
I certainly like from the training side and the NLP side, maybe being aware of this, because it really depends on what data you're training it on. Being aware of this particular, like we've tried to build systems. I'll be honest, like we've tried to build systems which where you invent a new handwritten notation and the AI needs to stick to it. And the AI is terrible. Like the vision models were terrible at this, like shockingly terrible. And so to some extent, I feel like maybe that's a training data problem, and maybe that's something that will be like improve in the future. But there's also a more futuristic vision of that, which is like, how do we then share out our notation? It's fine if we like develop some assemblage on the AI such that like we can like grow our notation that we use to communicate it with it, more or less accurately. Maybe we can reach that. I still think there's a lot of problems with the vision models on that front. But then how do we like update the weights of all other like for everyone else? Like how do we go about sharing the notation? And I think that's a more difficult question that maybe I'm not more as well positioned. So I think this research does raise a bunch of these questions about how we can have AI models that are not so fixed in the representations that they default to.
Okay. Can I ask a clarifying question too?
Yes.
So is your argument grounded on this premise that people intentionally seek to develop notational systems? Or is it more that notational systems are sort of like a byproduct or consequence for people's inherent need to find new ways to think and reason, right? Like if you think about the coordinate system from Descartes was a way to unify geometry and algebra. The intention wasn't to develop this notational system per se. So I'm curious as to which perspective you're taking of this talk.
I think when new situations arise, unforeseen problems and unforeseen situations, that's where we see the arrival of new notations, or people invent new notations to address those problems. So I would agree with that.
Okay, so it's an intentional process of finding a representational whatever notation.
Sometimes it's intentional. And sometimes it is something like the whiteboard, right? It's not so intentional. It's we realize that we can't ground as well. Like if we're communicating over whiteboard, we can't ground as well in what we're talking about just through natural language. And so we start to adapt, we start to develop ad hoc a notation in order to solve the grounding problem that we're having. Okay. Okay, so I'm going to get into some sort of historical examples. So prominent roles of metaphor in cultural adaptation. What is this? So I'm going to give many examples of this. So grounding metaphor. So at CHI 2023, researchers in France introduced this notion of a microgesture notation. As you can see here, there's little Morse code symbols. And their sort of goal was, we have all of this literature on microgestures in HCI, and we need to compare and contrast the different hand gestures in the literature, because it's kind of unclear. You have to watch the video in order to understand the differences, and we might want to catalog this. And so they were developing a succinct notation for people to write this down. And one of the interesting things here is you can see this initial dash here, the first dash on the left, is lower than the other dashes. And it doesn't necessarily need to be lower than the other dashes, but why is it lower than the other dashes? It's because it's grounding in our embodied experience of the hand, right? The hand and the thumb being lower than the other digits of the hand. And once you know where the thumb is, you then know where the index finger is, etc. So this was a deliberate decision by them. Another example of a grounding metaphor, so a metaphor to embodied experience, is, I really like this string diagram. There's a picture from the book Picturing Quantum Processes, where you have this string diagram, and the authors were adapting this string diagram notation, which is sort of mathematically grounded, to this to quantum category theory. And they show this really nice image where this transformation, as you would think, this transformation of pulling the string and then the shape rotates 180 degrees, you would think that this actually works out in the math, and it actually does, right? So you can do this transformation naturally. So this is an example of how they sort of invented this notation such that they're leveraging the perceptual capabilities of humans to understand what might happen next. One of the most common things we see in the beginning of the invention of a new notation, especially for a new domain, is a linking metaphor. where you're making a metaphor not just to a notation in another domain, but also kind of to that domain itself. One of the prominent examples of this is chemistry, is chemical formulas and the origin of chemical formulas. Berzelius, who introduced the modern molecular formulas like this, he was originally inspired by arithmetic notation, right? Plus, and you can see this as a picture of one of his earliest works, introducing the notation. And in this work and other works, he refers to this as, he refers explicitly to making this linking metaphor. He refers to it as arithmetic in mathematics. So he wasn't necessarily like, he was sort of using this linking metaphor to an existing notation to then later on form theories about the world. Another example of a linking metaphor is dance is music. How do we notate dance? Well, maybe we could look to musical notation. And perhaps the reason this happens again and again throughout history is because dancers and musicians are in the same place. Dance is set to music. Dancers can be musicians. And so for some reason, many people seem to naturally think of sheet music notation when they try to invent a dance notation. Now, what you see as notation evolves, however, is that these initial linking metaphors, so this linking metaphor here, it's not really apparent, like this is probably a pretty bad notation, if I can be honest, for dance, right? Like what is this saying, right? It links very directly to, I can see how it's horizontally similar to the staff and the sheet music notation here, but it's really unclear how this translates to a dance, right? And so because of these initial constraints, there's sort of a combat between metaphors, if you will, where the sort of closeness of mapping to our intuitive mapping of how dance would function doesn't really match up to the linking metaphor that was made. And so in this case, the evolution of Laba notation, which is a specific dance notation, evolved through this rotation by 90 degrees of the musical staff, whereupon it's much easier to sort of understand that, okay, maybe at the left-hand side of this diagram here is the left side of the body, the right-hand side is the right-hand side of the body, and the middle is like the chest area, right? And so it makes this mapping a lot clearer, but it breaks away from its original visual resemblance with sheet music notation. Now you might be asking, okay, you're going off talking about like chemistry and all of this, like, but what about, this is like a computing seminar, so what about computer programming? So we need to like eventually mention computer programming somewhere. And it so happens that I did some earlier research on the history of computer programming. And in fact, we see a very similar pattern in computer programming, this very prominent role of cultural context and linking metaphors. Here's an example from the ENIAC project. On the left, we have an image of some of the earliest flow diagrams. Goldstein and von Neumann introduced the term flow diagrams. And on the right, we have a picture of a block diagram from the ENIAC project. And really, the ENIAC project took place in an electrical engineering school. And there were tons and tons of these block diagrams lying around, right? And so it's not really a mystery then, once you see these juxtaposed side by side, it doesn't seem like such a jump, that one of the earliest programming notations looked a lot like the other diagrams that were sitting around in the same school that Goldstein and von Neumann were working in, right? Now, was this the most usable notation? This initial linking metaphor, just like dance, was the linking metaphor successful? Was this the most usable notation for the users? Well, that's questionable. Goldstein and von Neumann argue that it was. They sort of implicitly argue that, using this block diagram representation would make it quite clear to a relatively unskilled operator the general outline of the procedure, as they say here. However, did the programmers on the ENIAC project, did they find this a natural representation? Well, the answer is actually no. The programmers on the ENIAC project were largely women who were brought onto the project and given almost no training, and the majority of them did not have an electrical engineering background. And so as Bartik says here, I had never read a block diagram in my life. Betty hadn't either, and we assumed it was read from left to right like a book. So in this circumstance, they're applying their existing cultural knowledge to understanding the new situation. We see this prominent role of linking metaphor happen again in Fortran. So at the early stages before Fortran was sort of proposed by John Baucus, this is a snapshot of one of the problems he was working on at IBM at the time, called the Moon problem. He was basically tasked with inputting these long calculations into the machine and using the computer in order to perform these long calculations. And at the time, you would see these notations sort of interspersed with typewritten representations here. And he was sitting at the computer, and he was spending a lot of time sort of encoding these mathematical formulas into machine code. And so lying around the area, IBM was well known for its typewriters, for its key punches, alphanumeric key punches. And so he thought, well, what if instead of importing, instead of doing this translation process really slowly, why don't I just input the mathematical notation directly, right? And why can't I just use the keyboard to do this? And so when Baucus was inventing Fortran, he was not, as we might think of it today, like having deep thoughts about algorithms and the words that we might use today, conditionals, et cetera, et cetera. He was thinking more about a sort of on-the-ground practical usability problem of, I have these mathematical equations and I just want to import them into the machine, and that's my vision of what the optimal computer programming would be, is if we could just directly input these mathematical equations. So just overall, like, I've been throwing a lot of these linking metaphors at you. Hopefully you understand by now, like, notations across situations are actually heavily culturally situated, and linking metaphors, at least initially, are very, very common. And what we see as we examine the evolution of notations is that these initial resemblances fade over time. It's an example of the Toffoli gate in quantum circuit notation. If you see the right here, people who are familiar with quantum computing might recognize this notation. But actually, the Toffoli gate, it turns out, emerged from an initial grounding metaphor to crankshaft, so physical mechanisms, crankshaft mechanisms. And Toffoli, through a series of diagrams, shows how he's inspired by these mechanisms, and then gradually the details are abstracted away, first by Feynman and then Barenko, until you get the sort of modern notation we have today. A really prominent example, like where you can see this very clearly, is in SignWriting, which was invented first by Valerie Sutton and then sort of co-designed with deaf people and deaf communities over many decades. What's really nice about SignWriting that I found is that Valerie Sutton has a really great autobiographical history with many, many images, which isn't the case for many notations, so it's quite instructive. This is an example of SignWriting. This means the cat sees the dog and runs away fast, to the best of my knowledge, in ASL. So you can see here, cat sees dog, runs fast. And this is from SignPuddle software, which you can use online. Now, if I would tell you that, what is the inspiration, the original linking metaphor of this notation, right? I just showed you a bunch, this is a sort of modern form of it, but I just showed you a bunch of linking metaphors and grounding metaphors. What is the original metaphorical representation? People here might not say, well, of course it was sheet music notation, right? Of course it was music. But in fact, that's the initial linking metaphor that's made. So let me walk you through this. So we have sheet music notation. It didn't always look like this, but this is an example of how it looks at the present. And then we had a bunch of different people, not just Zorn, but for this purposes, I'm just showing you Zorn. Frederick Zorn invented his own dance notation, where you can see these sort of dancers are superimposed next to the staffs, the musical staffs. One interesting thing about this notation is there's actually a kind of picture of how the dancer is moving on the stage. This isn't something which all dance notations have. And what happened was that Valerie Sutton, when she was young and she was taking lessons in ballet, she saw Zorn's notation and she was inspired by it to create her own notation. She didn't necessarily follow Zorn, but she was inspired to write down the ballet moves that she was learning and invent what she called dance writing. And, you know, over many years, she sort of invented dance writing. This was her, I think 1973 is when she initially published it, actually. So it was many years before that she was inventing it. But she published it, and dance writing was noticed by academic researchers at the University of Copenhagen, who were like, hey, you know, we have some videotapes of signers, of sign language, and we want to sort of construct a notational system to write down these sign languages for archival, for comparison, for comparing across the many different international sign languages. And so they brought in Sutton, and Sutton sort of watched a lot of these videos and started to invent this notation. And she was, of course, heavily inspired by dance writing. So a lot of this looks like dance writing. Some of the staves of the musical notation drop out. But you can see how it's linear. You can see the use of sort of numbers that she was using here, numbers, and you can see numbers again appear here for the number of fingers that you're holding up. But as signwriting evolved, as she also started to work with deaf communities, some of these remnants of the original linking metaphor to music notation started to drop away. And so you see the stave is now completely dropped away, but you still maintain some of the linearization as before. You also see these numbers no longer appear, and you can see that the fingers now appear more directly for a more direct grounding metaphor. Then we lose even more remnants, and now the symbols are stacked. So this linearization, which was a remnant from sheet music notation, is now lost, and now the symbols are stacked, so it looks more closer to a mapping with how the body would look. Another interesting thing is this sort of the shoulders no longer appear. You used to have to keep writing the shoulders over and over, but they weren't adding anything, so people just stopped notating them. And then finally was this final sort of vertical transformation, which got rid of the sole remnant of musical notation, which is the bars. So how do notations come to be, at least initially, and how are they evolved initially? Well, key to the practice of inventing notation is this cognitive process of analogical alignment. You are applying your existing cultural knowledge of existing notations to the new domain. And in that practice of analogical alignment, some of those rules and assumptions that were in the source notation are broken as the metaphor is broken over time. One of the interesting and important things about this process is we know from experimental research as well that analogical alignment can actually obscure dimensions of variation in the target domain. So let me give you an example of what this means. So I showed you this picture of the whiteboard before. In the end, we didn't go with this notation. We haven't continued with this notation. It was productive for us, but there's a problem. And people who know Clark's work on Common Ground might be able to identify part of this problem, which is Common Ground is not so simply reached by humans, right? Unfortunately. My beliefs about you are different than your beliefs about me. We can still communicate even if we hold different beliefs about a project. And so this is kind of misleading notion of there's a simple overlap. There's also in Common Ground, it's important to understand I have beliefs about you that you might have that you have about me. So there's higher order beliefs. I have beliefs about you that you have about how you feel about your collaborator. And so Venn diagrams might have oversimplified things. They deceived us into thinking that Common Ground can be simply shared, but it's actually simplifying how is sharing common ground between humans and AI different than humans and humans? It's not altogether clear in this notation. But this process of using notation was actually insightful. It wasn't a complete loss. So one of the things we sort of ground on in our work is that a notation is not just about mapping dimensions of variation from empirical phenomena to perceptual phenomena. It's about what is meaningful to you. And so this example of the whiteboard, I have different entity types like human or AI. I have this notion of shared understanding. In the perceptual domain, I have notions of visually salient shapes, overlap between shapes, size, color, etc. And a notation is really performing this kind of mapping between these concepts. So over time, this formalization is not just about eliminating ambiguity, but it's also a process of deciding what matters to us. Formalization is a process of setting the values that concern us and what is most important and what is less. And so if we can code entity type and shared understanding, but then we forget these other parts of the empirical or conceptual domain that we're trying to model, then we might forget them, that they even exist over time. One thing that happens in history is if you didn't know about a particular phenomenon, like electrons and atoms, then later on, you need to actually amend your notation in order to introduce that variation. We see this with structural formula in modern chemistry, where sort of the discovery of covalent bonds and valence electrons inspired this extension of the existing notation, which needed to stick to the notation that was already set by Berzelius and others. Okay, so as a notation evolves, so initially we might, let's say we went with our common ground notation, and we were using that a lot, and a bunch of communities started to take it up. They might then reach this sort of stage of sanctification where the notation becomes a lens through which they see the world. And they no longer are, it's not as easy to see these dimensions of variation that were before less stabilized. So here, like higher order beliefs and external documents, we're not making these distinctions because the notation might impose a certain way of looking at the world. This happens a lot. One of the prominent examples is in ethnomusicology, where musical theorists argue that there's this kind of notational centricity, the fact that we equate music with like notated sheet music from the West, and that, you know, being a professional musician or being really well practiced in music is really understanding sheet music notation. So what? You went into all this history. Like I only have so much time. So we just did this work. There's even more in the paper. We'll come out with it a preprint hopefully soon. But what is the implications? I think there's many different implications of this work. I'm only going to give you a tidbit of some early sketches of ideas that we have. So like one thing that I take away from the work and that why I enjoyed doing this work is that I do think it's like an interesting and cozy reminder of history, of like, I have done a lot of LLM sort of centered evaluation research, and it is to me a kind of cozy break from all that AI research. But I do want to posit some other, early ideas for you, just to give a little tidbit of what I'm kind of thinking about. So normally, like I said at the beginning of the presentation, AI systems make it really easy for us to instantly formalize ideas, to go from the informal ideas to well-defined notations that are well represented in the AI model's training data. But we might also consider going in the other direction and positing sort of opportunities for us to make malleable, previously settled notations or formalisms. One example of this is if you write in Lua, there's many different reasons why you might write a game or something in the programming language Lua, but maybe Lua is really, really restrictive. I've tried to write in this format, and maybe you miss some of the constructs from other programming notations that you're used to. And so normally you would have to like write a specific parser or compiler for your variation of the notation. But nowadays, like what if we could just write in whatever notation we wanted, or making these sort of ad hoc extensions, like instead of having to say my function is function A, which is very, very verbose, maybe I missed this arrow notation from like JavaScript or TypeScript, and so I just write that verbatim, and I sort of let it up to the machine or the LLMs to figure out what's going on. So I think we could look for opportunities in how we're building these systems to make these kind of informalizing moves over time. In previous work, I made a kind of informalizing move, but along the lines of handwriting inside code. So here's an example of like quantum computing circuits with this notation that I was sort of inventing, where in Python code you can say n equals 8 or k equals the square root of n, but then you can use these symbols directly in the notation itself. And so you're sort of lifting part of the code into this land of informality, but everything still runs. Another idea, which is a bit more direct to what I've discussed today, is developing systems which could help people construct new notations, maybe for new tasks and new problems. And what would such a system look like? This is an early mock-up of such a system. I think one of the things we can learn is how we might reify these decisions that are being made in the early creation process of notations. So the dimensions of variation in the empirical or conceptual domain, how could we make these salient? And these mappings between these dimensions to the perceptual channels. So like here, shape is now sort of saturated by these different indexes of the finger, and then color is now a way that we're indexing the different fingers, right? And maybe the system suggests ways to simplify the notation, saying, well, we don't need to like draw all this complexity. Now we could just draw a line instead. Maybe you should consider this, or maybe you should draw from these different notations to be inspired and make these linking metaphors more transparent. Or maybe suggesting that our mapping of like the finger to color, the perceptual channel of color, is not really intuitive, and suggesting an alternative mapping. So overall, the questions for future research that I have is how we can develop new systems that dynamically ground the form, or not just the content, of human AI communication, when that form is not seen in the AI's training data. And so how can we co-invent these new abstractions with AI, which thereafter ground the AI's communication with us? And so maybe a vision of human AI communication can move us, this sort of vision can move us closer to what I think is more of the dream, which is we're collaborating with an AI like we might collaborate with a person over a whiteboard. And we might invent our own abstractions that we use in our labs, in our institutions, and co-invent them with AI, and thereafter communicate with AI through them. So thank you, and now I'll take questions.
Yeah, fascinating talk. I also appreciate the cozy history lesson. On the last topic, though, of human AI communication, it seems like a lot of your examples come from people in some ways reducing dimensionality or finding something more understandable based on a very common shared experience. They're visual. I mean, we're just so fast at visual information. We're so good at quick bodily reactions to things. And the models, at least at this point in time, they're good at tokens. They're maybe good at vectors in some sense. So do you see historical analogs? I don't know, for example, people who were good at different modalities of the human sensory experience or something, connecting in a way that's maybe more similar to how we might connect with AI? Or do you think that it's more just a translation problem and like the AI just needs to meet us where we are and it's more one party explaining it to the other rather than both coming together with a shared, capability?
Is the question whether like the humans will, like we come up with the notations and the AI just sort of takes it from there, or whether we can co-construct?
So yeah, or like how you translate those historical human examples where those are coming from a place of we just know embodiment is going to be very quick if we can put things together on that page, to one with a very different sort of entity.
If I interpret it right, I do think some of we're sort of making a normative argument here. I do think some of the long history of these notations evolution are like these sort of gradual realizing the usability isn't that good, and then like gradually making it better over time. And maybe if we had AI systems which are accustomed to this, they could like warn us early on that like the decisions that we're making are going to have broader ramifications and are probably suboptimal in some way, or in what ways they're suboptimal. So I think there could be ways in which like collaborating with an AI might be potentially better than collaborating with a human. If you're trying to construct a notation together, the AI might be capable of thinking of things that the human is not capable of. I still think that the vision models, they really struggle with some basic things around this problem. So there's sort of a performance problem, basic performance problems. But yeah, I do think that it is an interesting question how this might be different, how collaborating with an AI might be different. And certainly if we think into the future of like potentially if we want an artificial general intelligence, that AGI will, at least in my opinion, need to be capable of inventing new notations that then grounds its thinking, because that is a core component of human society and human thought and human knowledge. And if it's not capable of doing that, then it might not be able to, there might be limits. I don't know if I answered the question. Okay.
I have a question. I don't know how to best frame this. When I think about the brainstorm or collaboration process, it seems that especially at the exploratory stage or at the creative stage, there are a lot of ambiguity and a lot of like more like intermediate steps before I finally form a system or notation. So are there any guidance in terms of thinking about what are some kind of ways to handle those ambiguity, or how does those ambiguity or intermediate output even help shape the final notation formation? Does that make sense? Like it feels a lot of uncertainty and ambiguity in the process. How should we be thinking about that?
Yeah, that's a good question. So I think the Venn diagram example sort of brings up how it's not necessarily a failure if the practice of using a notation was helpful for you to reach a conclusion about what you might be overlooking or avoiding. And so like dealing with notations as a way of thinking through a problem together and coming to conclusions and maybe being somewhat throwaway, like the notation doesn't necessarily need to outlast the conversation. In many cases, it doesn't. It's more of the rare case in which it does, and which is why these stages, I sort of preface this by like institutionalization is a rare stage, sanctification is rare. Like it doesn't necessarily mean that it all has to. If we're creating new systems that support this process of identifying ambiguity, something that is an ambiguity can sometimes be cultural conflicts with like your domain knowledge. Like I am familiar with this notation, and therefore I'm reading this a certain way, and that's actually making it harder for us to communicate. So one of the ways that the general world knowledge of LLMs could like contribute in this capacity is like trying to anticipate those like kind of cultural conflicts, understanding the perspective of how someone else might, from a different background, might read the same notation could be one direction, one potential direction that you might go in.
Okay, thanks. There's a question in the chat. Do you want me to read it?
Oh, sure.
Okay.
I'm aware I can read it.
Okay.
I am aware that there are studies where LLMs can invent a gibberish language when they talk to each other. There's some reinforcement learning work on this. What are your thoughts about how this has emerged, and does this suggest that AI has the potential to create their own notation? Yeah, good question. Yeah, certainly. There's also a scary potential, like if it invents its own notation and then like they're communicating with a notation that we can't understand, like that's a bit of a alignment problem maybe. I think that it's a necessity that AI systems, as I just mentioned, can develop their own ways of communicating or their own notations and representations. I think also if we have AI systems which want to discover new science or start to discover and make scientific advances, they might need to invent new notations to like better explain what happened back to us. So there might also be sort of explainability aspect of notation development. Let me see the question again so that I heard there are studies. What are your thoughts about this has emerged? Yeah, so I mean, there's people working on it, and I'm aware that people are working on it. And I think there's particular dangers as well.
It seems like from the historical examples, there's these like new emerging fields in which notation provides a way to problem solve, like as new technologies or new problems emerge. And certainly, I think your work in quantum circuits and stuff sort of gets at that edge, right? Like new technologies, we have to start developing notations for that. I'm curious if you were to like work another year with like one group of people who are really invested in developing like a notation, who that, deep case study would be,
Oh,
Like less historical, but like almost co-designing the notational systems and AI supporting tools to augment them where they have these types of stakes.
right. There was two domains I was interested in, which is one is I mentioned before, like game design, because I think game design people already like sketch and that's part of the process. And so understanding how AI can support the process of game design rather than just like we prompt and then we get like a game out. First of all, I don't think that those systems do that right now, but I don't think that's very interesting as a game designer and other game designers. Like part of it is the joy of going through the process of creating. And so certainly when we were working on game design, because of the challenge of the visual representation, you often need to use a lot of notations in order to represent things. So that's one. But if I was thinking more scientifically, there was a time where I wanted to like collaborate with ML and AI researchers on like, you know, when they're developing different model architectures, right? Because that's like sort of at the advance, and you need different notations that are sort of emerging. They're not really formalized, but like emerging around how you represent those architectures. And perhaps if we had a better notation or more formalized notation around that, we could then more quickly think of improvements or alternative model architectures that we might then test. Exactly what I was saying, if you have a notation that describes the world really well, then you might move to the generative stage where you now generate theories about the world that you then try to test, right? So yeah, so if I had like the funding and sort of people are really, really interested, then maybe I would just sit in a lot of ML, sort of watch a lot of ML researchers' work.
Thanks. Yeah.
Okay, great. Yeah, with that, maybe let's give Ian another round of applause. And thank you so much for your wonderful talk.
Thanks, everyone.